Today I want to talk about building complex systems. Now, when you build a complex system, a lot of people have made observations based on their experience, and these have resulted in a number of laws. So, for example, most of you have heard of Brooks' Law, and even if you don't know the name, I'm sure you've experienced it. Brooks' Law says that adding more people to a late software project makes it later. Okay, so if I've got a lot of people working on a project, it's probably because it's a big and complex system. And so you've experienced the fact that when you try to add more people and it's a late project, so you're already well into it, then you just slow everything down, because the additional people that you bring in, they're not aware of everything that's been done in the system before. Any help that they give is generally more than offset by the errors they introduce. Also, when you introduce more people, you introduce higher complexity, you introduce more decision paths. You've all experienced that two people deciding where to go to dinner, yeah, you can decide fairly easily. 3 people, 5 people, try to get 10 people to agree on where to go to dinner. And all of a sudden you understand the implications of adding more people to a project. It just slows everything all down for many reasons. Hofstadter's Law, I'm sure you've all experienced too. It always takes longer than you expect. And it's interesting that this law is stated in recursive terms. So it says, even if you take into account Hofstadter's Law. So, why does it always take longer than we expect? Because when we're building these types of complex systems that we build in Scrum and in software development, there's so many unknowns. And the very nature of an unknown is you don't know what you don't know. And so we always assume that things are going to go reasonably well. Yeah, there'll be a few hitches, but they'll go reasonably well. Never so. There's just all kinds of unanticipated things, and it just takes longer. Conway's Law is another interesting observation in building complex systems, where he says the organizational design will essentially be mirrored in the architecture of your system. So, for example, if you have 2 teams building a compiler, it'll be a 2-pass compiler. If you have 3 teams building a compiler, it will be a 3-pass compiler. So just to the nature of communication structures in an organization, which is essentially how the teams are built and put together, if you look at the architecture of the resulting system they've built, whether it's software or an aircraft or whatever, you can see in the architecture the organizational design. The 99 rule is kind of like Hofstadter's Law. That is, the first 90% of the code takes 10% of the time, and the remaining 10% takes the other 90% of the time. So it always takes at least double of what you thought, because it's at the end that you do all the system testing, you do all the integration, and when you test, you find all these bugs. When you try to integrate, you find the pieces don't fit. And that's where things fall apart, is at the end, and that's why the end always takes so long. But those are laws that have been widely experienced. People tend to understand them, whether they take them into account or not. But those aren't the ones I want to focus on. Today I want to focus on Gall's Law. Has anybody ever heard of this in the audience? All right, well, let's take a look at Gall's Law. Gall's Law says a complex system that works is invariably found to evolve from a simple system that worked. The inverse is also true, right? A complex system designed from scratch never works, cannot be patched up to make it work. You have to start over, beginning with a simple working system. This is just a fundamental truth about building any complex system. Whether you're building an aircraft, whether you're building a software system, You start with a simple system that works, and then slowly over time you can evolve it into a complex system. So just to give you an example of this, I have a short video that actually shows what we mean when we say incremental development. That is, start with something simple, evolve it to something complex. So here we go. Notice the crucial features in this video. He builds something very simple and then he tests it. He demonstrates it, shows that it works. Now, just that simple thing works, and then he makes it a little more complex, integrates everything, tests it, makes sure it works, demonstrates it, in this case to himself. But in a business context, we would demonstrate to the business people and the actual end users. Now, notice here, when he tested something, he found a little glitch. So he went back and modified things and set the spacing down a little bit so it would slide in easier. I suppose you didn't find that glitch until the whole thing was built. Notice that in every case he also knocks over the dominoes to make sure that the output of what he's creating is correct. right, so there you have what I think is a pretty good demonstration of building a complex system by starting with a very simple system and then incrementally adding on features until finally you have a more complex system. And the pieces there were all very well illustrated. Every time that he built a simple piece, he demonstrated that it worked. He integrated all the pieces together and made sure that it accomplished what it was supposed to. Then he added another little piece. Then he added another little piece. And you can quite successfully build a large complex system like that. But what do our organizations do? You know, they don't do that. They build systems that fail. Why do they fail? Well, John Gall not only is the author of that law, but he wrote a book about how systems work and especially how they fail. It's a pretty old book. It was published back in 1975, but the principles are absolutely as true today as they were in 1975. So he unfolds his reasoning a little bit, and he says there's two reasons why that our complex systems, you can't build a complex system from scratch. He said the first one is it's difficult, I'm going to say it's impossible, to specify upfront a complex system that optimally meets system goals. Okay, so done some consulting and work with a consortium of automotive companies that are designing the software for self-driving cars, so the autonomous driving platform, combination of hardware and software. Now, if you try to sit down from scratch and design a self-driving car and design all the sensors that you'd need, all the automation, all the computer systems, and you design the whole thing, and then everybody implements it exactly according to spec, and you try to put it together, I mean, it's pretty obvious that that would fail, because you know, if you design all these components separately, when you try to integrate them, obviously they're not going to fit and they're going to fail. But also, you just don't know up front what the optimal solution is. You don't know exactly how many sensors you need. You don't know exactly the right algorithms. You don't know exactly how to determine your positioning with GPS and what you need to augment the GPS with. There are so many unknowns and so many complexity, you just cannot get it all right, or at least you might build something working, but it won't be very optimal. You can't get it optimal in the beginning. It's just too complex. And then the second thing is, not only is it cognitively too difficult, our brains are too limited to deal with this amount of complexity, but even if we did kind of design things all correctly up front and write them down in a detailed spec, no matter how carefully you think you've designed a spec, different people will interpret it differently. And so if you have different teams, different people building different parts of the machine, each one understanding their spec according to their understanding, and then you put them together, they're not going to fit because not everybody's going to understand everything exactly the same. And there's going to be bugs. And if you don't find the bugs up front, you don't find the inconsistencies up front, you've got a real mess when you try to put together this large complex thing. So you've got to do incremental integration. Of course, the buzzword is continuous integration. And not just continuous integration to make sure that technically it works, but continuous demonstration to make sure that you're actually achieving the optimal business goal. Because we're looking for two things. We're looking for an optimal solution to meet a goal. What's the optimal technical thing to do? But we're also looking at optimally solving some business problem. The integration and testing helps us solve the technical piece, but the continuous demonstration helps us solve the business piece. And way back in 1975, John hit the nail on the head when he said, just don't do these things. Now, most of us that are targeted in this talk here are IT professionals, but this holds true for any kind of complex system. And there's some really disturbing data out there. We build, professional IT people, we build very complex systems. And the Standish Group, it's kind of an old report, but it shows that 70% of IT projects were not considered successful. There's more recent research from McKinsey that find 17% go so badly they threaten the very existence of the company. So no matter where you look at the data, how old or how new it is, you will find that way too many projects fail, or at least are not optimal, aren't even considered successful. Now, why is that? Well, it's because we ignore Gall's law, right? We think that if we are careful enough, so we hire really smart architects, we create very intricate notations, and we think that the best way to solve problems is to create this detailed specification up front. But Gall's law says, forget it. It's too hard. It's perhaps impossible. And then we go off and we don't integrate incrementally. We don't demonstrate. We try to build the whole thing and then put it together and demonstrate it. Now, I'm a certified Scrum trainer, and I want to point out that Scrum explicitly hits both of these issues. The first one, that it's difficult to design a complex system up front, Scrum addresses by starting Scrum with a goal. Scrum says, forget it. Don't even try. Do not try to specify entirely your system up front. Instead, focus on the business goal. What am I trying to achieve? So for a complex system like a self-driving car, start off with a specific goal, such as my goal is to design an autonomous driving vehicle that can drive more safely and more efficiently than a human. That's a pretty clear goal. You can keep everybody focused on exactly what they're supposed to be doing, is building a car that can drive more efficiently. That is, there should be fewer traffic jams, I should get where I want to go, less congestion on the road, and it should be safer. I should avoid the human error that causes so many accidents. So we start out with a very clear goal. Now, of course, we're going to have some sort of idea of how to get there. So we start out with some ideas, but we expect that those ideas are going to evolve as we build little pieces, as we test them, as we demonstrate them. All of this will evolve. So Scrum honors Gall's law by saying, don't even try up front to specify in detail the whole system. Start with, in fact, what we call a business goal. And this has been re-emphasized in the most recent version of the Scrum Guide, which itself evolves. Now, the other part, incremental development, that's explicit in Scrum because we say at the end of every sprint, some short period of time, 1 to 4 weeks, you need to produce an increment that you can demonstrate that is meaningful to people who are not technical. How you get there, that's the technicians. But now I've got something I can demonstrate, and a business person can see it, and they can see, does it solve what I want, and so on. So the fact that the technical people have to put it together in a demonstratable way, that solves the technical piece, but then that I actually show it to those that it's supposed to give value to, that solves the building the right system piece. So we have built into Scrum this very fundamental notion about building complex systems, which was articulated by John Gall way back in 1975. Now, Gall's law has an implication on the role of an IT professional in an organization. And companies that neither understand nor apply Gall's law, which unfortunately is many large traditional companies, how do they treat their technical staff? Whether you are an electrical engineer, whether you're a computer scientist, whether you're a graphic designer, whatever, they tend to treat you as an order taker. You know, your office is in the basement off somewhere. You are not seen as strategic, you're seen as tactical. The business is strategic, the business tells this tactical IT machine what to do, and they execute the detailed instructions of the business. And you as an IT professional are simply an order taker. You just do what you're told. Just shut up and do it. Okay? Well, I might have fun as an IT professional doing what I do, but just being an order taker is really not as rewarding as if I worked in a company that did understand and apply Gall's law. If I work in such a company, then I'm treated as a business partner. And instead of my job is to simply take a detailed spec and implement it, my job is to continuously collaborate with, in Scrum it's called the product owner, but the business side, I need to collaborate with the business to create a system that maximizes value to the organization. Now, I should probably make a law out of it, but the idea is that the specification of a system cannot effectively be done by either the business side or the technical side alone. Optimal complex systems are always designed by a close collaboration between the business, who understands the value they need, and the tech side, who understands possibilities, cost-benefit trade-offs, all those kinds of things. Okay? So what do I mean by a collaboration? I did a lot of work with Skype a number of years ago, so I'll use an invented example illustrating kind of in Skype. So let's suppose that as a business partner, or as having someone dictated to a business analyst, as a technical person, I get a specification that they say on the Skype splash screen, what we'd like is the ability to configure a button that if you press this button will automatically start a video with some designated person out of your contact list. Okay, and I could give you a very clear specification of how big the button should be and where it is and how to configure it and how to set it up. And of course, we don't want a button on everyone's screen. We just want to give the user the ability to do that. Now, if I asked you to do that if I was a business person and I asked you as a technical person to do that, you will make some assumption about why it is that I want to allow people to do that. Now, I've asked technical people, given just that information, why do you think that someone would ask for that ability? And I receive all kinds of answers. One person said, well, maybe I would like to configure a button for tech support so I could immediately start up a video call with tech support and people could walk me through, or and people come up with all kinds of ideas of why they might want to do that. But in fact, so the fact is, if the reason that you come up with internally in your head, you think, well, I want this because, if you don't guess right, if you think the real reason for doing that is different from what the real business reason is, you'll get the implementation wrong. It won't really satisfy the need. Why? Because the technical people make all kinds of decisions that are not explicit in the requirements document. I don't care if you write 1 page, 10 page, 100 or 1,000 pages, you cannot fully specify a system so completely that the technical person who implements it isn't going to have to read in between the lines a little bit and make some assumptions. So, in order to build an optimal system, you don't want the technical staff making incorrect assumptions. So you have to tell them not only what to do, but why you want them to do it. Now, this is where the business partnership comes in. If you say why you want to do it, then they can come back and dialogue with you, and they can say, well, maybe there's a better way to do it because they see technical possibilities. Or they can say, we can do that, but the cost is, and you say, oh, if it's that much, I wouldn't want to do that. And you actually can start making some good business decisions. So just to give you an example, suppose that the reason the business wanted a button up there is because they were trying to get into the senior citizen market. Okay? And so if any of you who are listening to this, you do tech support for your grandma or your mom or your elderly relatives, you'll know that they don't like to sort of figure out a system. They want a recipe. So I'll give you an example. Last time I was up visiting my mom, she wanted to know, I think it was something like how to watch back episodes of Price is Right on her computer. Okay? So I said, okay, Mom, then log into www.nbc or abc, whatever the network is, .com. Okay, I said, now look for the menu that says programs. I said, wait a minute, where is that? And I said, okay, you see these 3 bars over here, click on this, and then go down to where it says programs. She says, where is that? And I said, well, look, it's right here. So she counts. She said, okay, 1, 2, 3, 4. Okay, go down 5 and click. And I said, well, Mom, all right, just look for programs. No, I have 5. And then once you get programs, then, okay, look for prices, look for categories, game shows, okay. And so I was trying to get her to understand, look for this type of thing, look for this type of thing. And she was saying, no, go down 5, click, go over 3, click. And I said, Mom, but if you write down that detailed formula, they're going to change the menus because they're always adding new stuff, evolving things, changing the interface. You have to understand how to get there. You can't just write down a formula. And she says, yes, that's the way I'm going to do it. And she says, I'll tell you what, if they change the menu, you'll have to come back and tell me how to find the new one, and I'll write down a new formula. I was like, oh my. Okay, so now suppose that Skype was aware of that, and so they said, what we want is the ability to configure so that my mom could put a button up there that would start a video with, let's say, her granddaughter, who might be in her contact list, and she can configure the video and put it on the screen where she wants, and then that button stays there, and no matter how much they change the menu system, her little configured piece stays there. Now, if as a developer you understand that, now you can start having a dialogue. You can start making a better system. If you're a partner, you can say, wait a minute, if you're going to build into the system the ability to configure a button like that, you also have to build in the ability, or at least make it easy to use a third party to do so. But you have to think about the fact that even Grandma has this capability, she's not going to be able to configure it herself. So we have to make sure that it's going to be easy for Grandma's tech support to log into her computer and configure her screen with a button for each one of her grandkids or whoever she wants to talk to. And now you start having this rich dialogue between the technical people who are thinking about the technical aspects, thinking about the cost, and just brainstorming about better ways to build the system. And they're dialoguing back and forth. And this dialogue between the business people and the technical people, that's what builds an optimal system. And so in an organization that understands Gall's law, they treat the technical people as business partners, and they not only accept, but they solicit their input on how to make the system better, how to make the system optimally fulfill business goals. Okay? So that's the role of an IT professional. It's very different. So am I going to work in a company that doesn't get Gall's law? I'm going to be an order taker. I'm going to work in a company that gets Gall's law. I'm going to be a business partner. Now, why, what does it mean to be a business partner? Well, first of all, you're going to have to learn to talk without an interpreter. How many of you have seen illustrations where that a business analyst was set up explicitly in an organization to be the interpreter between the business people who speak business language and the technical people who speak technical language? And when you try to put the two together, they don't understand each other. And so we hire a business analyst who listens to the business people, translates it into technical specs, and hands them to the technical people. Now, if you're going to be a business partner, we don't do that. We eliminate the role of a business analyst as an intermediate. We still may have a business analyst, but they would be on the team and they would lead out in knowledge elicitation, document writing, and so on. But the team would be involved. The whole team would be a set of business partners. It wouldn't just be the business analyst. And so now as a business partner, you have to learn how to talk to business people, and it can't be technical gobbledygook. Right? I've seen technical people try to convince a business person why they should upgrade to a new database system, and they're talking about automatic voice code checking and stored procedures that can do XYZ, and the business person say, "What are you talking about? Voice code, normal, stored procedures?" If you want to convince the business people to upgrade to a new database, you have to talk in business sense. You have to either say things like, okay, if we can upgrade to this new database, this report that used to take 20 minutes to run, it'll now run in 10 minutes. Okay, that I understand. Or you might say, if we don't upgrade, then we have to pay a fee for every time we have a maintenance request from them. And those fees are such and such. Whereas if we upgrade to the new system, we get automatic support for some number of years. And given the average number of times we have to request technical support from them, we would more than pay for the upgrade by having a year's free support or 2 years or whatever it is. But those kinds of things. And so generally in Scrum, it would be the role of the Scrum Master to help teach the team to communicate in business terms and business vocabulary. So if you're going to be really a business partner in a organization that understands Gall's Law, you're going to have to learn to talk without an interpreter. You also need to help the business articulate their goals. I've found this so many times. So the business is used to treating me as a techie as an order taker. So the business will say, blah, 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 I want to be able to put a button, or I want to do this, or I want to have this table be exported to this format. And I say, okay, why do you want to do that? And so either they will just say, well, it's none of your business, just shut up and do it. Or they will find it very difficult to, well, I want it because I want it. That's basically what they'll say. I want it because I want it, because I need the data in that format. But they don't really get behind. So I've often found that to be a good business partner, you have to kind of guess why they want it. And then you tell them to guess, well, I think you want the data in that format because you want to be able easily to see those customers that are more than 90 days in area. Okay. Now, if you guessed right, they'll say, yeah, that's why I need it. Isn't that obvious? But quite often you'll guess wrong. And they say, no, that's not why I need it. I need it like this because what I want to do, and finally you can get it out of them. But I just find for some reason, and I've done this a lot, very hard to get the business people always to clearly articulate a goal. Sometimes they either because it's difficult for them or they just don't see the need. Just do what I say. But I found it very, very helpful over and over again. If I guess, well, I think you want this because, then they'll either confirm or deny. So be a business partner. Learn to talk without an interpreter. Learn to help the business articulate what they're really after. Now, why do you want to be a business partner instead of just an order taker? Can't I just sit in my rubber room and sling code and is that sufficient? No. And the reason is in big bright red letters here. They do that cheaper in India. If you think as a Java programmer, or whatever your technical skill is, to write Java code, well, they write Java code in India and they do it cheaper than you'll do it here. And they're starting to do this in India, you know. In India, if you think your job is just to, well, they'll do it cheaper in Afghanistan or whatever. There's always, you know, a new place that, you know, is coming up that'll do it a little bit cheaper. So if you, in this global world, outsourcing is a fact. I mean, just look at the statistics on this page. Okay? You don't want your job to be outsourced. And if all you do is a well-defined technical thing, you take a detailed spec and you produce it, then your job is not secure because they do that cheaper someplace else. But if your job is to use technology as a business partner to collaborate with the business to help them optimally meet their business objectives, and you now have a strategic function rather than just a tactical function, they can't outsource that. It's very difficult to collaborate with someone multiple time zones away, no matter how good they are or articulate they are. I've taught a lot of courses in India, and I know there's some, you know, qualified, good technical people over there, but it's very hard to collaborate with people 12 time zones away from you. And even though I know technology is getting better, there's still nothing quite like face-to-face for collaboration. So you want to be a business partner for many reasons. It's more fun, it's more rewarding, but also it's a lot more secure for your job. Now, be a business partner, but also practice incremental development. Okay? At the end of every sprint, put the stuff together in a way that you can elicit meaningful feedback. Okay? So if you're building an accounting system, at the end of the first sprint, you can't have a database design or an architectural drawing or a bit of Java code, because the business person can't see that. They can't evaluate it. That's not incremental design. If I'm building an accounting system, maybe at the end of the first increment, all I have is, let's say, a login system. Doesn't do much, but I can demonstrate it. Or maybe I just have the ability to create a chart of accounts. That's all I can do. But I can create a chart of accounts. You can add accounts to it. You can change if they're, you know, debit or credit. You can change the tax information on them. The rest of the system isn't there. It doesn't work. But that little piece works, and I can demonstrate it. Then I build another little piece. But it has to be some functionality that an accountant can understand, not just a technical person. That's the key to incremental system. Not just that I build a bit that technical people understand, but I build a bit that's integrated, that's functional, that a business person, that a user can understand. Okay? Now, sometimes this feels like you're not getting much done. I have a colleague that contracts for software, and they were contracted to build the control software for these big diesel engines, like, you know, for big diesel generators for cities and that kind of stuff. Of course, there's a tremendous amount of software control for these big engines. And so they were contracted. And so in the first 2 to 4 weeks, I mean, you know, how much can you get done? But they understood Gall's Law, and they wanted something that they could demonstrate, that they could integrate so they know they had something working, and that they could demonstrate to their business people. And it turns out all that they could get done in the first increment was they could hook up their software to the control panel on the side of the diesel engine, and they could light up, power up the control panel, turn certain lights on, and then they could power it down. That's all they could do. Is they read all the documentation, understood all the API, and they were able to hook up to the control panel, turn it on, turn it off. That's it. They were very almost embarrassed to try to demonstrate that to their customer because it looked like they didn't have hardly anything done. But in the spirit of Gall's Law, they went and they demonstrated it to their customer. And much to their surprise, their customer was ecstatic. Their customer said, wow, look at what you've got. You've already got the hardware saw talking to the software. I can't believe that. You guys are amazing. The team we just fired, they worked for months and they had a whole bunch of who knows what, but they couldn't even get it hooked up to our system. They couldn't even work the interface to our system, and they blew months. So here's this illustration again. I built something very simple, but I could demonstrate it. I could integrate it. And in this case, the customer thought that that was extremely valuable. Okay. I could go on with many other examples. You can even do this with testing electrical fencing on a farm. You can do it incrementally rather than putting up 20 miles of fence and then finding out it doesn't work. You put a little stretch up, test it, make sure it works, put a little bit more up, test it, make sure it works. This principle is widely applicable. Now, be aware that as a developer, when you start building like this, it will feel slower, but it's in fact faster in terms of delivering value to the business. Now, why does it feel slower? Well, because we're used to just writing code, throw a few tests at it, but basically we do what we're doing, whether we're developing an electrical system as an electrical engineer, whatever we're doing, we do our technical piece, we do it fairly rapidly, and then we throw it over the wall to a systems test group or whatever. Now, this feels fairly rapid to us because we get our part done pretty quickly. And then we build the next thing, We feel like there's progress building all these components, building all these pieces. But when does the customer start to see things or start to get value? Well, we've got to test everything. We've got to integrate everything. And you remember the 90-90 law, right? That the remaining 10% takes 90% of the time. So what we don't necessarily see as a technician sitting in our own little cubicle is that the customer doesn't get anything for a long time because of all this integration nightmare, reworking pieces, all the testing that has to go on, and so on. Whereas if we build a little bit, and if you're doing multiple teams, then all the teams still have to get together and integrate the stuff. And it feels slow. In fact, it is slower from a component perspective, but from a systems perspective, it's faster because I build my component and then I got to take time to test it, integrate it with all the other components, demonstrate it. That takes time. But now that piece works. And in some cases, there's enough there that the users, the business can actually use it and they're getting value right away. Okay. I found this in spades. I was doing some consulting with a group in Canada a while ago before COVID, and I interviewed I had done some training for them in consulting, and I was called back to kind of do a refresher and evaluation about 6 months after the original training. And first I met with some of the management, the product owner, the business side, and I asked them questions about, okay, as a business, do you feel like you are getting value faster than you did in the past? And it was an unequivocal, yes, we're getting value faster. I said, do you feel like the stuff you're getting is better prioritized? You're getting higher priority stuff? I say, absolutely. Okay, so then later after I met with the business side, we met with everybody. We had the business people, but we also had all the technical people there. And I asked the technical people, what's your perspective? Do you think that things are going faster or slower? And it was funny because the technical people said, oh, it's slower, whereas the business people said it's faster. Okay, so it feels slower because from a component perspective, you just don't do a little bit and then you don't see it anymore. It feels slower because you've got to do the integration, the testing, the demonstration. But doing all of that gets value faster to the end user. All right, so both are important, right? Be a business partner, because if you're just a techie, they do it cheaper in India. The technical side, continuous integration and demonstration. You've got to do that so that you build the right system, that's the demonstration, and you avoid this huge risk of integration failure, that's the continuous integration. Now, I would hope that you all work in perfectly agile organizations that really understand Gall's law. Many of you may not. So you have a role to play in helping your organization understand Gall's law. And you can't do it as effectively only by training or persuading or verbal things. Demonstration is really what's needed here. So being valued as a strategic business partner. So actually be a business partner. Even if you're treated as an order taker, you can still say, okay, I think you want me to do for this, and you can enter into dialogue. You can also be a good business partner by building the thing incrementally and demonstrating it incrementally. And that's not only good for you, it's good for your company. Because it just, when you can see the value of what you do and there are fewer failures. I've worked in teams where we built this big complex system and, back 20, 30 years ago before I knew all of this stuff. And we'd build this big complex system and try to put it together and it would fail. I see multi-million-dollar systems that the team invested their heart and soul and energy on, and it ended up getting thrown away. That's very disheartening. So if you can be a strategic business partner, you can reduce the number of failures that you will work on, which will make your job so much more rewarding. And of course, as a certified Scrum trainer, I have to point out, if you practice Scrum, these principles are embedded through and through in the Scrum framework. So that's the thing I would also recommend to you. So thanks for listening. Here's my email. Feel free to follow up with questions or whatever. And look forward to when we might meet in person.